afternoon. I asked for this meeting with you because I want to discuss why the project that we have in front of us to develop a new interface design for the accounting system, why I believe that it would be better to use the unified modeling language system versus the traditional system development process that we normally do here at this company. The number one reason that we want to use UML is communication, to hopefully enhance the communication between the technical people, the design team, and others involved in the development of this system, and the business people, the managers, the lawyers, and the people involved from that end, and even the users. We want to be able to increase and enhance the communication between those people. UML is worth using in this case for several reasons. First of all, it does provide a standardized set of tools to document the analysis and design of software systems. This documentation will again help when communicating between the lawyers and the managers of the office and the IT team, because that seems to be where we have our issues, that we have a very technical document that is sometimes difficult to get across how the system performs to people who may or may not be so technical. UML also includes diagrams that will help users to visualize the construction of the system. Our current system right now is very limited. We are using 3 different systems across 7 offices. And what we hope to do is put in place a system that can grow to fit our needs, but even right now that can accommodate all the offices. The current system we have, there is no proper documentation, and the development team that put this system in place, they're no longer with the company, and we're not able to reach them even when we want to make changes to that system. One of the things about UML, or one of the proper things that we should discuss, is that it consists of things, relationships, and diagrams. In this case, things is referring to structural things, including classes and use cases. Relationships in this case refer to behavioral relationships as well as structural relationships. Diagrams in this case, we're referring to structural diagrams, and those can include class diagrams, including use case diagrams, which we're going to talk about a little bit further. The 6 most commonly used diagrams in UML are use case, which we'll talk more about, use case scenario diagram, activity diagrams, sequence diagrams, class diagrams, and state chart diagrams. Analysts should always and will always start with the use case diagram. This is basically a diagram that describes how a system is used. The use case diagram will include actors. In this case, that would be users and other systems. For instance, this is related to the accounting system, but we would have the user identification system and other systems that will communicate with the accounting system. So we would have the actors in this case, as I described, as well as what the user goal is for even using the system. Why is anyone using this system? The diagram will include what the system does, not how it does it. This is a very broad view, sort of a top view, and it's not very detailed at this level. An example of a very basic use case diagram is this one here, where I've created a system that's going to create the bill. This is just one use case. So what we have here are 2 actors. We have the billing curve here, and we have the server here. They're represented by stick figures. And within this rectangle, which is demonstrating our system, we are identifying the various requests and processes that will happen here. So at the end of this, the goal here is to create a bill. The billing clerk wants to create a bill. So she has to work with the system. And the first thing she's going to do is submit the attorney ID and the hours he worked. That's what she's going to put into the system. The server will receive that information, and then it will do some processing there and send back a statement. That statement is received here by the billing clerk, and that statement is used to generate the bill. So that's a very top-down view of one process that has to happen for the accounting system. This is only one use case, and of course there will be many more. Okay, so I mentioned briefly that we want a scalable solution, and by that I mean a solution that can grow as our needs expand and as we even expand in people. In this specific case, this is going to be useful for us because with a scalable solution, those objects will allow for us, the system implementers, to address resource needs at that level. For instance, if we need more hardware in the specific area of, say, for instance, the accounting portion where they only deal with user hours. If we need more resources there, hardware, storage, whatever, for those databases, we can add the resources exactly where they're needed and not have to be fixed or locked into a very static solution. So in this case, for instance, we currently have the 3 different systems. We would have one very large system, but if we were to acquire another firm or acquire an entire department that would have 100 new billable users, we need the ability to add hardware at that part of the system and not have to dismantle the whole system and start from scratch. We also mentioned that one of the reasons that we wouldn't use the traditional development process here is because it's very fixed and not scalable. That system is best when you know exactly what you need in a system and you do not anticipate a lot of changes. And here, of course, we do. One other thing we want to talk about is that we mentioned that it will facilitate communication across all the various stakeholders. That, again, includes the people who have to make those decisions, the business people, the technical people who are making the recommendations, and then the users who actually have to use the systems once they're in place. In a traditional sense, the communication is usually restricted to the team of whoever is developing the system, and not all the stakeholders are involved, or the expression is far too technical for laymen, and that can sometimes present a problem. That can present a problem when actually producing and providing the communication. Another key component here, or a good feature, is that in this abstract system, you're able to create as-is and to-be solutions. For instance, if this happens, we do this. But if this happens, we do that. These sort of abstractions are very helpful and allow you to have more flexibility in the system. One of the elements that we're missing in our current accounting system is that we have offices internationally, and so the current accounting system does not provide for the kind of flexibility to input different denominations of currency. So with something like this that has abstractions, it can be managed, the size and the complexity. So we would want to have a complex currency system and have the ability to switch currencies or even convert currencies where necessary when perhaps a lawyer stationed in the U.S. has done some billable work for the Dubai office, for instance, and we need to figure out a way to generate an accounting system or a bill appropriate for that kind of work and that kind of task. Another thing is that this project doesn't have to be worked on in a linear fashion. We wouldn't have to complete this stage, then this stage, then this stage. We can work on these things concurrently and have a very little risk that we will disrupt some other aspect of it. With UML, we will also be able to detect errors and omissions early in the development cycle and not have to get all the way to the end to find out that we've missed something and have to start all over from scratch. So with the reusability factor, that's a key thing here for this specific project because it will save us some money to reuse codes and objects and not have to rewrite every single piece of code. Um, Inheritance will help a lot with that. The inheritance that's in this system that will allow us to maintain the existing program code. Um, these are things that were not available to us in the traditional systems, and these are things that we would be find very useful if we use a UML development system. What we found and what I suggest is that for this specific project and with proper training, a UML development system is going to be much better for us for this project because this is very data driven. Whereas a traditional system would be more appropriate to something more process driven. Here we're going to be dealing with changes to data, changes to actors, changes to objects. There's going to be change and growth. So it's best for us for this specific case to use a UML development system.